All right, hi everybody. I'm so sorry that I couldn't make it to class today. I got to take care of some personal stuff. Got to be out of town. So hopefully this video will kind of serve as a decent substitute. I thought about still having class meet and having a different teacher come in there, but I was afraid that that would disrupt things more than it would help you guys. You know, someone with a different style, not quite understanding what we do on a daily basis might be less useful for you guys. So I don't know. I debated between the options and thought that this was hopefully the best one for you guys that I go through and essentially record a video doing what we would have done in class today. All right, so what I would have done if we were in class today is I would have started out by writing all this stuff up on the board like I always do, reminding you that you have homework due tonight. I'll write Thursday here because I don't necessarily know that you'll watch this on Thursday. I'm recording it on Wednesday, but by the time you watch it, maybe it's tonight anyways. Then you have a quiz that's due tomorrow, and the corrections, as always, due Saturday. And on that quiz, it'll cover two different, I don't know, homework assignments, sections, whatever you want to call them. This 3.3 and 3.4 section is what we went over on Tuesday of this week. And I think what I told you is there's really, I mean, it's one goal. You can just do it in either order. I'm going to give you the equation of a factored polynomial. So I won't write that. I'll say like f of x equals negative 3 times x plus 2 squared times x minus 1 to the third power times x plus 5. Sure. Right? Some factored polynomial. And I'm going to ask you about the end behavior. So make sure you write that in proper notation. So like as x goes towards negative infinity, y goes towards positive infinity, if that's what you think the answer is. And as x goes towards positive infinity, y goes towards, I don't know, negative infinity, whatever. And then I'm going to ask you about the y-intercept. And then I'm going to ask you about the x-intercepts, aka the roots, aka the zeros. I think I use one of these two terms. And then also their multiplicities. So lots of vocabulary being thrown around. Make sure you understand what all that means. And then after answering all of these questions, well, you might as well graph the thing, right? So you sketch an approximate graph. And when I say approximate, I just mean make sure you capture all these ideas in here. So this is what I'm going to ask you to do on the quiz from 3.3 and 3.4. In theory, you could go this way. I could give you the graph and ask you for all this stuff and then the equation. I think these are the last couple problems on the homework. I didn't. Could have. Could have kind of gone in this direction, but didn't. All right, so what I'm going to do is give you this and ask you for all this stuff. Try to make it as straightforward as possible. That's 3.3 and 3.4. What we're going to talk about today is 3.5 and 3.6. It's very similar. All right, we're still dealing with polynomials, and we'd still like to be able to come up with an approximate graph, and we still can go backwards if we really want to, but we're not going to. All right, it's almost the same. 3.5 and 3.6, we want to do all this same stuff. The only difference is that our polynomial is no longer in the factored form. And that's a bummer, because it turns out it's way harder if your polynomial is not in the factored form. So it won't look like this. It'll look like f of x equals 3x to the fifth power minus 4x to the third power plus 12x squared minus 11x plus 5. It won't be that nasty, actually. I think it's a third degree or fourth degree polynomial, but it'll be something like this. And essentially, what I'll want is an approximate graph. But rather than ask you that, because this is so laborious, I think that's a word, what I try to do in these problems is always ask you for the same things in the same order. So what I will ask you to do are list the possible, sorry about my dog crying in the background, really wants to go to the park. We'll go after this video. List the possible rational roots, and I'll explain what that means in this video. Test one specific root. So in reality, you list all the possibilities and you just kind of test them until you find one that works. But as I talked about in the videos that hopefully you've watched, I don't want you just hunting blindly for them. So I'll tell you one that does work. And I just need you to know how to test it. Find the factor corresponding with that root. It's like my dog's singing a song. I don't know how well you can hear that, how well the audio picks up. Find factor corresponding to that root. So essentially what that means is like if you decide that 3 is a root, then that means that x minus 3 is a factor. And then you do polynomial long division. We'll get some practice with that in this video. And then you'll find the remaining roots. It turns out that when your polynomial is in its unfactored form, when it looks like this, finding end behavior and the y-intercept are a lot easier. Like the y-intercept is 5 because of this 5, and the end behavior, based on the fact that this is odd and this is positive, it's going to go up when it goes to the right and down when it goes to the left. Right, it's easier when it's given in this form than when it's given in this form, but the roots are way, way, way harder. So really, my goal for 3.5 and 3.6 is for you to be able to do all this same stuff, but usually I don't even bother testing you on these first two because it's so easy, and you proved to me you could do that in 3.3 and 3.4. But if you had these two and you found the roots and their multiplicity, then you could give me a graph. So in theory, I can ask you to do all this stuff, but since I'm asking you to do all of this stuff in 3.3 and 3.4, I really just focus on the thing that's new, which are these roots in 3.5 and 3.6. So what I'm trying to say is on your quiz, from 3.3 and 3.4, we'll do all this stuff. From 3.5 and 3.6, I'm just going to ask you to find the roots. You could do the rest of this stuff, but I'm not going to. And you'll see the homework does that same thing. You're not doing a lot of graphing. You're just doing this over and over again. It's a long process, but the good thing is it's very predictable. So it's one of those things that tends to go either really well for students or really poor for students. This is going to end up being a page in your final exam, I can just tell you. And it's very predictable, so for that reason, a lot of students will get 20 out of 20 on that page, but it's also pretty hard. And so if you don't know how to do it, it's easy to get really low grades on this kind of stuff. Anyways, that's what you should expect to see on your quiz. So what I want to do for the rest of this video is work through a few of the homework examples shown above and drew them in this fashion, right, to really prepare you for what you'll see on the quiz. So without further ado, let's work through a few of these problems. I don't think there's quite as many as usual. What do we end up with? 11 of them. It's a little less than usual, I think. And the last couple here are different. I don't know. When you deal with complex roots. The good news is you don't have to worry about that on this week's quiz. It's good to understand complex roots, but I believe that your quiz kind of stops after question 7. So the quiz is more like these up here. This is good stuff to know. Final exam, maybe. Extra credit at some point, maybe. But as far as short term, don't stress about these. All right, so let's do a few. The first 1, 2, 3 are all the same. How about that? They're all just polynomial long division. And the reason I ask you to do the same thing over and over again is because when you go through this big process, which is what you'll be doing on the quiz, one of these steps is polynomial long division. So numbers 1, 2, and 3 on the homework, do just this step. Because that tends to be the new thing for a lot of students. And then when you're good at that, we go through the whole process and that'll just be one step. So I won't do it 3 times for you. I'll let you do it for some of these. I'll see if there's any of these that are tricky. I think this one's the hardest just because it's the longest. So maybe I'll do this one. No, I'm going to do this one. You can do the shortest and the longest. I'll do the medium one for you. Because it doesn't really matter, I don't think. Yeah, that's what I'm going to do. Okay, so polynomial long division. You think like long division. And I'm not going to teach this like it's brand new because hopefully you've watched the videos on this. But the idea is you take your little denominator there, your x plus 2, you kind of write that on the outside of this long division sign. And then the numerator, the x cubed plus 9x squared plus 16x plus 10. Hey, you're okay. And you write that underneath this division sign. And it really helps if you line things up in columns. So I like to space my terms out a little bit. You don't have to do that, but it just makes it a little bit easier. Note that in this case, I have an x cubed term, an x squared term, an x term, and a constant term. I'm not missing any numbers in there, right? 3, 2, 1, 0. But here I am missing something. So we'll get to that in a minute. Let's start the polynomial long division. The idea is you work from the left to the right and you want to get rid of this x cubed. How do you get rid of this x cubed? Well, it turns out you get rid of that x cubed by putting an x squared up there. Why? Because the next step in your algorithm is to take that x squared and multiply it by x plus 2. So x squared times x plus 2 gives you x cubed plus 2x squared. The x cubed times the x squared times the x is the x cubed. The x squared times the 2 is the 2x squared. And then, just like the long division algorithm, if you learned that way back in the day, you subtract. And that throws a lot of students off, so be careful. Make sure you subtract here. X cubed minus x cubed goes away. That's good. I should be getting rid of one column in each step of this algorithm. 9x squared minus 2x squared is 7x squared. Be careful, it's tempting to write 11x squared here. You're not adding, you're subtracting. Then you bring down the next row, and I got this 16x. Now I just repeat. If you can get that far, you're good. I just repeat. Just like I wrote this x squared up top to get rid of this x cubed, now instead of getting rid of x cubed, I'm trying to get rid of a 7x squared. So to get rid of a 7x squared, I'd write a 7x up top. Why would I write 7x up top? Because 7x times x plus 2 gives me 7x squared plus 14x. Wait, slow down. Where'd that all come from? 7x times x is 7x squared. 7x times 2 is 14x. And then don't forget that you have to subtract. 7x squared minus 7x squared, that column goes away. 16x minus 14x leaves me with 2x, and I bring down that plus 10. One more time. Do this one more time. Now, instead of my goal being to get rid of this x cubed or to get rid of this 7x squared, my goal is to get rid of this 2x. How to get rid of the 2x? Toss 2 up top. Why? Because 2 times x plus 2 gives me 2x plus 4. Subtract. 2x's go away. The 10 and the 4, when I subtract them, leaves me with 6, and I'm done. How do I know I'm done? Because this degree is less than this degree. Because I just have a constant down here. That constant ends up being my remainder, so that goes into this box, the number 6. And the quotient is what you have up top, this x squared plus 7x plus 2. That mess right there. Right, so that's how you do polynomial long division. It'll be a little bit easier up here, because instead of starting out with an x cubed, you start with an x squared. So instead of having to do this 3 times, you only have to do it 2 times. Be a little bit harder down here, because instead of starting out with the x cubed, you start with the x to the 4th. So you have to do it 4 times, but the process should be the same. Just be really careful with your negative signs when you're in here. If you were subtracting a negative, for example, that means you're adding. I went over that really carefully in the video, so if you struggle with that, watch those videos, please. The other comment that I want to make, even though I think I said it in the video, is when you're setting up this problem, put the x minus 4 out here, you write your big long division sign. I got x to the 4th power. I got 5x to the 3rd power. Note that there's nothing squared. Right? I got 4th power, 3rd power, 1st power. Kind of skip the x squareds. It makes life easier if you put in a 0x squared. You don't have to. Feel free to ignore my advice if you want to be a rebel and go against me. It's fine. I don't care. But it'll make your life easier if you put in this 0x squared. If you're ever missing a term, and when I say missing a term, I mean look at the degree of the polynomial, and you should have a term with an exponent corresponding with that number and one less than each. That's not even making sense. You know what I mean, right? 4, 3, nothing, 1, 0. 3, 2, 1, 0. Great, I'm not missing anything here. 2, 1, 0. Great, not missing anything here. 4, 3, missing the 2, 1, 0. Since you're missing the 2, put in a 0x squared. And then just do the process exactly like you did up here. But by putting in that 0x squared, it'll make things line up easier for you. You don't have to do that. It'll make your life easier. I've already spent way too much time on this. That's polynomial long division. It's one of the steps, but it's not the only step that you'll need when you're going through your quiz. So here's question 4, which is more like, I guess, a quiz problem, although it cuts out some of the steps. It says, factor the following expression completely given that one of the roots is 8. So, okay, if one of the roots is 8, the way to think about this is you're kind of at this test. You test one specific root, and you find out that one of the roots is 8. So we haven't learned how to test one of these specific roots yet, or I mean, you have if you watch the videos, but we haven't done that in this homework. But you'll learn how to test a root, and then you'll figure out that that a number really is a root. So maybe you test 8, and you're like, yeah, that works. That's a root. Cool. If 8 is a root, then you have to find a factor corresponding to that root, and that factor is x minus 8. So what you do up here is, once you figure out that you have a root at 8, that means x minus 8 is a factor. That's really important. And I talk about why that works in the video, but maybe for the sake of brevity, I'll just say, yeah, you understand all that? If x minus 8 is a factor, I can do polynomial long division. I can take x minus 8 and divide it into this polynomial. X cubed minus 8x squared minus 100x plus 800. Wow, all right. Comment here. When this is on the quiz, don't expect hundreds and 800s floating around. Expect these numbers to be a lot smaller. Another comment here. Because x minus 8 is a factor, that means that x minus 8 must divide evenly into this polynomial. That means that the remainder that we saw in questions 1, 2, and 3 must be equal to 0. So it's a nice built-in check. So what I want to do is my polynomial long division algorithm, just like I did on question 2 up here. Maybe I'll go a little bit quicker. Get rid of the x cubed by putting an x squared up top. Why? Because x squared times x minus 8 is x cubed minus 8x squared. And then I subtract. I have to make sure that my first column goes away. X cubed minus x cubed. That's gone. Cool. Then I look at my next column. Negative 8x squared minus negative 8x squared. In this specific case, that all cancels out, and I get 0x squared. All right, that's kind of nice. I got rid of 2 columns. I don't have to get rid of 2 columns. You only have to get rid of the leftmost column. But since I got rid of 2 columns in this case, instead of just bringing down the next column, I'll bring down the next 2 columns. All right, and that's kind of an oddity. That doesn't typically happen, but in this case, that ended up happening. If you get rid of 2 columns at once, that's fine. Doesn't mess anything up. Just in the next step in your algorithm, bring down 2 columns instead of 1 column. Now my goal is to get rid of this negative 100x. How do I get rid of this negative 100x? Better toss a negative 100 up top. Why? Because negative 100 times x minus 8 is negative 100x plus 800. And then I subtract. Note that negative 100x minus negative 100x is the same as negative 100x plus 100x. So this column goes away. And 800 minus 800 is 0. My remainder is 0. That's a nice check. What this means is that this polynomial can be rewritten as x minus 8. Since 8 was a root, x minus 8 is a factor. There it is as a factor. Times this quotient, x squared minus 100. Like, cool, I'm done. I factored it. No, you factored it. You haven't factored it completely. I'm sure it says that somewhere. You've done this. You haven't done this. Why? Because x squared minus 100 can be factored. You don't need polynomial long division or anything fancy like that. You just recognize that this is what's called a difference of squares. This is a perfect square. This is a perfect square. So it factors as x minus 10 times x plus 10. Often what happens in these problems is you start out with a 3rd degree polynomial. You find a factor that's linear, so your quotient will be 2nd degree. And then you'll have to factor that 2nd degree polynomial. Typically when you factor 2nd degree polynomials, it's more like, let's see, this, for example. And you rewrite it like this. But sometimes your linear term is 0, like it is in this case, and then it factors as a difference of squares. So this is the more standard example, probably more like what you'd see on a quiz. But they don't always work out that way. Sometimes 2 columns go away at once. That ends up producing something like this. Here's my totally factored form. That'd be the answer to question 4. Question 5 is a lot like question 4. The only difference is they give you the information in a slightly different way. Up here, it said one of the roots is 8. Therefore, I know that x minus 8 is a factor. Polynomial long division, factor, I'm done. Right here, it says when this polynomial is graphed on a standard coordinate plane, one of the x-intercepts is located at 4, 0. That's giving you this exact same information, right? X-intercepts are roots. 4 is a root. That's really important because what that means is x minus 4 is a factor. If x minus 4 is a factor, I can do polynomial long division, divide this thing by x minus 4. And what that will leave me with is x minus 4 times something. I don't know what it'll end up being, right? Some number, some polynomial here is f of x. Note that up here, they wanted the completely factored form. So you're done at this step. They didn't want the roots. They wanted the factored form. So you're writing this into the answer. You're not writing x equals 8, x equals 10, and x equals negative 10, the 3 different roots. You're writing the factored form. In question 5, they don't want the completely factored form. They want the roots. All right, so what you'll write in here is list the zeros, aka roots, means the exact same thing, of all the other x-intercepts. So when I say other x-intercepts, I mean don't include 4. We already talked about that one. So you're going to end up with x minus 4 times some 2nd degree polynomial. This 2nd degree polynomial will produce 2 roots, and you're going to write those 2 roots in here. All right, you'll get 3x squared plus something equals 0. Solve that, put your answers in here. Answers should be integers or exact fractions, no decimal approximations. For example, if your x-intercepts end up being negative 8 and 2/7, you would list them as negative 8, comma 2/7. All right, so that's the kind of the format they want it all listed in, and you'll figure out what those are. And I'm not going to do this, even though I do want to give you practice factoring when the leading coefficient is not 1, because I think there's problems down below that I'm going to want to do, like 6. I think I love 6, or 7 for that matter. I want to do 1 of 6 and 7 because those are the ones that are most like what you'll see on the quiz. Do I care? Do you care whether I do 6 or 7? They're both pretty miserable. I think 7's harder. Yeah. So let me be a nice guy and do number 7 for you. Oh, this problem's miserable. Okay, so the idea on question 7 is you're given this polynomial, and you want to list all the possible, I don't know why all is in bold, possible should be in bold, rational roots for this polynomial. So for this, you need to know that possible rational roots are always of the form plus or minus p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. Okay, so that's kind of unfortunate that they're both 4s. This 4, I look for all of its factors. 1, 2, and 4 are the only whole numbers that divide evenly into 4. This 4, coincidentally the same, typically it won't be, I look for all of its factors. I get 1, 2, and 4. Take any of these numbers divided by any of these numbers, and I get a possible rational root. So my answers for possible rational roots are plus or minus this number over this number, 1 over 1, 2 over 1, 4 over 1, 1 over 2, 2 over 2, but that's just 1. I don't need to write that again. 4 over 2, but that's just 2. I don't need to write that again. 1 over 4, 2 over 4, but that's 1/2. I don't need to write that again. And 4 over 4, and that's 1, so I don't need to write that again. My possible rational roots are these 10 numbers, right? Plus or minus 1, 2, 4, 1/2, and 1/4. They don't let you put in the plus or minus. So what you got to do is write like 1, -1, 2, -2, 4, -4, 1/2, -1/2, 1/4, -1/4. Sorry, that's kind of tedious to type those all in. Those are all the possibilities. They don't want the possibilities, they want the actual roots. All right, I couldn't get this video done before I left town, so I'm now coming to you from a different state. I'm down in California now, and I'll finish up this video. A couple of comments here. I think when we left off, we had come up with this list of possible rational roots. And then what the problem used to say is, all right, find the actual roots. And I mean, fine, you can do that if you want, but that's not exactly what it'll look like on your quiz. So what I did is I went in and changed this problem a little bit so it looks more like what it'll look like on your quiz. So if you go into the homework here, you'll see this problem, question 6 is the one we were working on. You still list all the possible rational roots, and then you're still going to find the actual roots and put them in here. But note that I added like this little thing right here. I guess we're working on question 7, but I changed 6 and 7. It'll say that doesn't make sense. Check the x equals -2. All right, well, what are you going to do? Check x equals -2 and x equals 3. Check that x equals -2 and x equals 3 are roots of this polynomial. I guess I want a that there. I can change that. Then use them in polynomial long division to find the actual roots. So the idea is, go back over to this problem, you could theoretically test each of these roots independently. When I say test them, I mean put them into this function and make sure that 0 comes out. And if 0 does come out, then you got a real root. And if 0 does not come out, well, then you don't have a root. But that's super tedious, right? That'll be really hard to do all that calculation. So a better idea, the methods we learned in this section, is just test them till you find one that works. But even that's tedious, right? I don't want you to have to test these. So I'm going to tell you which ones work. So maybe I would say test x equals -2 to show that it's a root. And you'd understand that what it means to test a number to show that it's a root is you take and put it into the polynomial that you have listed right here. And you make sure that 0 comes out. So let's see, I'd have 4 times -2 to the 4th power plus 20 times -2 cubed plus 33 times -2 squared plus 20 times -2 plus 4. And I don't even know if I have to say this, but in case I do, on a quiz, you wouldn't see numbers anything like this. Right, you'd probably be testing a 1 instead of a -2 to make the math work out really nicely, and don't expect to see 33s and 20s and such. Expect to see much smaller numbers. But anyways, we can deal with this. -2 to the 4th power is positive 16, and 16 times 4 is 64. -2 cubed is -8, and -8 times 20 is -160. -2 squared is positive 4, 4 times 33, 3 times 33 is 99, and another 33 would be 132, I think. And then 20 times -2 is -40, and then I got this plus 4. And this equals 0. Don't believe me? Let's see, on the negative side, I got -160 and -40, so I got -200. On the positive side, I got 64 and 132, so that's 196 plus 4 more. Hey, I did this right. It's positive 200. -200, positive 200, 0. What that means is that -2 is a root of this polynomial. And so what that means is that you can do polynomial long division. Or I guess I should take another step. That means that -2 is a root, and therefore x plus 2 is a factor. That's important. It gets like an exclamation point or something. If x plus 2 is a factor, I can use polynomial long division to start to factor this polynomial. I can take x plus 2 and divide it into 4x to the 4th power plus 20x cubed plus 33x squared plus 20x plus 4. You probably don't care, but the reason I didn't finish these videos is because I went through and did the entire thing and it wasn't recording. I was so bummed out, and I just slammed my laptop down and was like, I'll take care of it when I get to California. So I'm doing all this for the second time. Anyways, I want to get rid of this 4x to the 4th, so I'd stick a 4x cubed up here, because 4x cubed times x plus 2 gives me 4x to the 4th plus 8x cubed. And then I subtract. First column goes away. Good. I'm doing everything right. 20 minus 8 leaves me with 12x cubed, and I bring down a column, 33x squared. I want to get rid of this 12x cubed. Stick a 12x squared up there. That'll give you 12x cubed plus 24x squared when you take this and multiply it by this. And you subtract again. Leftmost column goes away. That's good news. 33 minus 24 sounds like 9x squared to me. Minus 20x. To get rid of this 9x squared, we stick a 9x up here, because 9x times x plus 2 is 9x squared. Oh, that's supposed to be a plus 20x. Sorry. Plus 20, plus 20. Plus 18x. And I subtract again. And when you subtract, you get 2x, which I would normally write right here, but I'm a little low on room, so maybe I'll stick it up here. No, I won't. That's going to confuse people. 2x. And then bring down that 4. Got to get rid of this 2x. How? Throw a 2 up there. 2 times x plus 2 gives me 2x plus 4. Sure enough, I get a remainder of 0. That's good. Big old check mark. Means I'm doing things right. Right? That means that x plus 2 really was a factor. I did my polynomial long division right. Then I can factor this polynomial, f of x. I can rewrite it as x plus 2 times 4x cubed plus 12x squared plus 9x plus 2. Okay, bad news here. I mean, good news is we don't have a 4th degree polynomial anymore. That's cool. Bad news is we still have a 3rd degree polynomial. On the quiz, I'm going to start you with a 3rd degree polynomial, kind of like you see in this problem, so that after you go through this series of steps that we've done, your quotient will be a 2nd degree polynomial. And you can factor that 2nd degree polynomial to be done. Right. Unfortunately, in this problem, because I started with the 4th degree polynomial and now I have a 3rd degree polynomial, so I'm not done. I got to go through this process one more time. What I would really do is list the possible rational roots of this polynomial. So factors of 2 divided by factors of 4. When I say this polynomial, I'm talking about this 3rd degree guy right here. Factors of 2 are just 1 and 2. Factors of 4 are 1, 2, and 4. Either of these numbers divided by either of these numbers, plus or minus, make up my list of possible rational roots. So I get 1 over 1, 2 over 1, 1 over 2, 2 over 2, aka 1, 1 over 4, and 2 over 4, aka 1/2. So unlike before, where I had 10 possible rational roots for this 4th degree polynomial, I only have 8 possible rational roots for this 3rd degree polynomial. In theory, you would go through and you would check them all individually, and you'd get really frustrated, and you'd get annoyed, and you'd finally find one that works. But I decided to give you 2 that works. So test x equals -2, and, well, in this case, it's x equals -2 again. But I changed the code a little bit, so you'll see 2 different numbers here when you get to do this problem. Test x equals -2 and x equals +3 or something like that. If it were +3, you would take 3 and put it into this polynomial and see that 0 comes out. But if you put 3 into this polynomial, 0 will not come out, because 3 is not a root of this polynomial. Look, I listed all the possibilities here. -2 ends up working again. Right, don't believe me? We could take -2 and put it into this polynomial. So 4 times -2 cubed plus 12 times -2 squared plus 9 times -2 plus 2. And I got what? -8 times 4 is -32. It's late, and I'm going to screw one of these up, and I'm going to be so mad. +4 times 12 is 48. Not that mad, let's be real. 9 times -2 is -18, and +2. On the negative side, I got -50. On the positive side, I got +50. That sure sounds like 0 to me. Wait, what did I just do? I put -2 into this 3rd degree polynomial. 0 came out. So x equals -2 is a root of, excuse the arrows, that polynomial. And x minus 2, nope, x plus 2, x minus -2 is a factor. If x plus 2 is a factor of this 3rd degree polynomial, I can do polynomial long division again. You're like, really? Yeah, just for the homework. You're not going to do this on the quiz. I can do this repeatedly on the quiz. 4x cubed plus 12x squared plus 9x plus 2. Maybe I can try to fly through this pretty quickly. Let's see, I want a 4x squared to get 4x cubed plus 8x squared. Subtract, you get 4x squared plus 9x. So toss a 4x up here because that gives you 4x squared plus 8x. Subtract, you get 1x. Bring down the 2. Get rid of that by putting a 1 up here. 1 times x plus 2 is x plus 2. Sure enough, remainder of 0. Cool. What that means is this third degree polynomial can be written as x plus 2 times 4x to the second power plus 4x plus 1. That was a terrible place to write that. But remember, my original polynomial f of x, maybe taking advantage of some color here, is x plus 2 for this one times this third degree polynomial, which is what was factored in green here. So I'm almost done. Right? I have f of x, my polynomial, written as a product of a linear term, and this quadratic term. Oh, so close. All I got to do is factor that quadratic. 4x squared plus 4x plus 1. Factor however you want to factor. One way you can factor is the guess and check method, where you're like, all right, to get 4x squared, I either put a 4x here and an x here, and then figure out what numbers go here. Well, they have to multiply to 1, so I put a positive 1 here and here, or a negative 1 here and here, but regardless of what I choose, I'm not going to be able to re-get this 4x. I kind of FOIL things out. So I must have guessed wrong with the 4x and the x. It must be a 2x and a 2x here and here. To get my 1, I could put a positive 1 here and a positive 1 here, a negative 1 and a negative 1, but by putting positive 1s in these spots, when I FOIL everything back out, I recreate this 4x squared plus 4x plus 1. Anyways, mercifully, I think we're just about done. The polynomial in its completely factored form is what goes down here. Right, that's this thing. In other words, x plus 2 squared times 2x plus 1 squared. Either way is totally fine. In fact, if you felt like it, you could think of these 2x plus 1s. There's 2 of them, like these 2 right here. You could factor out a 2 from each of them. If you pulled out a 2 from this one, a 2 from this one, you'd have a 4. You'd still have these 2x plus 2s, so x plus 2 squared. And then each of these 2x plus 1s would now be x plus 1 halves, because I pulled a 2 out of each of them. So I could also write the polynomial in its factored form this way. It doesn't really matter this way, or this way. It's all the same thing. And I believe the system's smart enough to accept any of those as your answer here. Like, you skip this part. Yeah, but this is the easy part, right? The actual roots. Well, we got roots at -2. Shows up twice. You don't have to write it twice. And -1 half. Wait, where'd that -1 half come from? Set this equal to 0 to find the roots. Or set this equal to 0. Or set this equal to 0. Right, x plus 1 half equals 0. So therefore, x equals -1 half, which is what goes right here. Anyways, that problem, it's miserable. I don't know. The good news is you only have to do it once, right? I had to do it twice because I didn't record. 6 is kind of like 7, but it's a lot more doable, right? It's more like what you'd see on the quiz. This is a good one to practice for the quiz. I don't know, maybe I can write this, like quiz practice. This will be pretty similar to what you'll see. It's a third degree polynomial. The numbers are decent. And note that I'm going to give you numbers to test, even though you don't see them on the screen in front of you. If you go to question 6 here in the homework, you do see them. Check that. Hey, this time I wrote it right. Check that x equals 3 as a root of this polynomial. Then use it and polynomial long division to find the actual roots. X equals 3 as a root. X minus 3 is a factor. X minus 3 divided by this thing will leave you with the polynomial. And that polynomial, here we can just look at it. There's the x minus 3. And the quadratic will be factored so that it's 3x plus 2 times x minus 2. With these specific numbers, if you're really lucky, you'll see these same numbers. Probably won't. But maybe you can do something similar for question 6. Okay, so that takes us through question 8, I think. Let me go back to my notes here. Question 7? Yeah. This is the stuff that you should expect to be on the quiz. This is the stuff that I need you to know. This is the stuff I'm going to test you on. Below this, it's stuff I'm supposed to show you. Stuff that I'm not super concerned with for our class. I'm hesitant to say I'll never test you on it. I certainly won't test you on it on this week's quiz. And if I were to put it on the midterm or on the final, I'll warn you beforehand. I haven't written your final yet. But the idea with questions 8, 9, 10, and 11 is they're all kind of the same. 8 and 11 are pretty similar, and 9 and 10 are pretty similar. And the idea is they deal with complex roots. So I made a video, and it's the last video in this section, and it shows you what to do with complex roots. Basically, the idea is, in this case, we have this quadratic function, and we're only given one root, 5 plus 8i. How are we possibly going to make this work? Well, complex roots come in conjugate pairs, as you'll see in that video. And the conjugate of 5 plus 8i is 5 minus 8i. And just like if negative 2 is a root, x plus 2 is a factor, if 5 plus 8i is a root, x minus 5 plus 8i is a factor. Similarly, if 5 minus 8i is a root, x minus 5 minus 8i is a factor. So I got my other root, which will go right here, and then it says, if the leading coefficient of this polynomial is 1, careful, there could be a number out in front, but I'm making it 1, so you can ignore that. What is its equation in standard form? That's a bummer, because otherwise you could just write this right here. But this ain't standard form, this is the factored form. So what you have to do is FOIL this out, right? So do this x times this x times negative 5 minus 8i. I'm going to write it. If you FOIL, you will get x squared. This x times this term gives you negative x times 5 minus 8i. This x times this term, it's a negative times a positive again, so it gives me negative x times 5 plus 8i. And then this times this is a negative times a negative, so it's a positive. And it's 5 plus 8i times 5 minus 8i. We got rid of these big parentheses. Now maybe you can get rid of the little parentheses. These little parentheses are easy, just distribute. I think you'll find some terms cancel out. These parentheses are a little bit harder. You got to FOIL again over here, but you'll find some stuff cancels out. And when you distribute all the parentheses, you'll know you did something right if you're left with no i's at all. When you have no i's at all, you got the standard form. You can type that right there. So that's the idea for question 8. And actually, that's kind of the idea for question 11 too. For question 11, you're told that the leading coefficient is 1 again. Oh, that's awesome. And you're given the following zeros, negative 2 and negative 10 plus 2i. But wait, if negative 10 plus 2i is a root, because complex roots always come in conjugate pairs, negative 10 minus 2i is also a root. So I got these two roots. Maybe I can find the two factors. Maybe I can multiply the factor that corresponds with this root and the factor that corresponds with this root, and all my i's will go away. I won't be done. I'll still have a factored form. It'll be x plus 2 times some second degree polynomial, but this says you can leave your answer in factored form. Just make sure there's no complex coefficients, meaning you multiply together the two factors that correspond with these roots, and you'll get rid of all the i's, and you'll get some polynomial here, x squared plus something, something there. And this can be your final answer. You don't have to go any further than this. So 11 will end up feeling a lot like 8 in terms of the work that you do. It's just 11 also has a real root at negative 2, but fine, just write that as x plus 2. The other two problems, 9 and 10, are pretty similar. 9 and 10, the idea is you're given a root here, x equals 3. So that gives you a factor, x minus 3. You can do polynomial long division, x minus 3 divided into x cubed plus 7x squared. I'm not going to do the whole thing, don't worry. Minus x minus 87. You can do a whole bunch of work. You're going to get 0 remainder. You're going to be really happy. You're going to have something up here, x squared plus something. Right? And then you'll have a second degree polynomial. We got one root, 1, 0. It's at 3, so that's one of my answers because I'm supposed to find all the zeros. And the other two answers will come from taking this and setting it equal to 0. Problem, when you take this and set it equal to 0, you won't be able to factor. The reason why is because the roots that you're going to get are not going to be real numbers. They're going to be complex numbers. But good news, I showed you how to deal with that in the videos. You can either use the quadratic formula or complete the square. And you'll get two more roots. They'll end up being complex conjugates of each other, and you'll write them here. So they'll be something like, they're not these numbers, but something like that, for example. Those will be your 3 zeros. You'll be done with question 9. And then you can do question 10, the last one. Question 10 looks miserable. It kind of is, not going to lie. But it's good practice, I think. The good news is I give you the two real roots, 4 and 5. All right, so we can do x minus 4, divide that into this polynomial. That goes here. You'll get some third degree polynomial, something here, right? And then, since 5 is a root, we'll do x minus 5 and divide that into this third degree polynomial. So that goes down there. And that'll leave you with a second degree polynomial here. I don't know what it's going to be. Then you'll take that second degree polynomial and set it equal to 0. Sure, I'll do the same thing I did above. And it'll be just like what happens up here. I'm going to get rid of that. You won't be able to factor because there's not real roots, because the only real roots are 4 and 5. You already have those. Those will be 2 of your 4 answers. But you can use the quadratic formula, complete the square, and you'll get 2 complex roots following the methods of the videos. So again, something like 3 plus 2i and 3 minus 2i, those aren't the right numbers. Those will be your 4 answers, and you'll be done with this homework. It's good for you to be able to do this stuff with complex numbers. We'll talk about whether it's reasonable to have this on the final. I don't know how much you're going to struggle with this. If it goes okay, it'll be on the final. If not, I don't know. We'll figure something out. But for this week's quiz, we're done up here. It's just this stuff in green. In fact, it'll be a lot like this problem. All right, I got to go to bed. Hope this is helpful for people. Let me know if you need anything from me. I'll be back in town on Sunday, but I'll have access to like email and stuff while I'm down here. So if you need anything, just reach out. All right, bye.